Hey everybody, it's Keith with the L1 Automotive Training Channel, and today we're going to help out another YouTuber that can't fix a car, right? And this package hails from the land of New York. Eric over at SMA sent us this. Let's open it up and see what's inside. Some newspaper. Oh, score! Oh. That's what I'm looking for. 2 for $5 for the GIF to go. Sweet! And he writes, this PCM sets a P0880 original with the correct VIN, and this is the donor used PCM, known good, wrong VIN. This is a Hyundai something or other, or a Kia, but it's a Hyundai. It says Hyundai on it. The issue is this car starts and runs and drives with this PCM, and it fixes the problem. Eric diagnosed this 100% correctly. Anyone that doubts his ability to diagnose a car is out of your mind. The joke of all this is that, look, these are made to be written one time. You can only write the VIN to a Hyundai PCM that's new and blank one time via OBD2. Hold up, is this getting kind of confusing? Well, if it is, you guys can head over to L1training.com, and I have hundreds of hours of advanced level training. We cover diagnosis, module programming, EEPROM, immobilizer, keys, board repairs, all of the great stuff you guys have questions about at L1training.com. Most of these classes are done live, so we have these Q&As where you guys can ask questions, and I answer them right there. Head on over to L1training.com and sign up, and we'll see you guys there. Once it's written, the VIN doesn't change. There's no tools on the market that via OBD2 will rewrite the VIN number. So he's just sent it to me simply to take this VIN number and write it into this PCM. So we've got to open these up to do that work. And in order to fix some of the issues, to fix the issue with that, we can't just rewrite the VIN and type it in. You can, but sometimes you'll get a checksum error. So we're going to use some specialized software to extract the data from this one and write it to this one to change the VIN. And we're actually not going to change the software. We're just going to make sure it's up to date. So we've got the original module here. We've got our HexProg 2, our brand new HexProg tomorrow technology, but I have it today, so we're good. We can fix this thing today. We're going to open up the HexProg Tune software. We're going to select it by ECU. Oh, there's a new update available. We'll do that momentarily. And I've actually already selected it. I was pulling it up because I was going to show you an interesting anomaly. So we go to Hyundai. This thing is a SIM 2K 141. And let's see. You can see right there, it's a SIM 2K 141 Siemens VDO. So we have a Continental and a Siemens option. Obviously this one's a Siemens. Even the board is labeled SIM 2K 141. Something also that's interesting is this has already been opened once before. I didn't do this. Here we select the Siemens with the MPC 563. We click next. We click wiring. We scroll down and we look at the circuit board. And you can see in comparison to what's on the screen that I'm superimposing and what we actually have in front of us, they do not match. So let's go back and check that Continental one. Now it's not every module will have multiple brand options, but it happens to be the SIM 2K 141 has a Siemens and a Continental option. So now we'll select the Continental. We'll look at the wiring and look at this picture of the circuit board. And if we compare the picture of what we actually have and what we have on the PC, we can see they do match. So we're going to use the Continental option, even though the original and the donor both say Siemens. So scrolling down, we're going to Use boot mode. Looks like we've got to connect the cables as shown to the BDM connector, or the, I don't know if it's JTAG, BDM, or what it is, but the actual quick connect section on the board. So let's go ahead and get that soldered to that, and we'll be right back. Another thing that's going to help us connect to the board easier, this one I just got open. This is the donor. We're going to put a little liquid flux on there. I usually like to use Amatex, the paste flux, but we've got liquid right here, and I'm just kind of using the soldering iron on up there. We're going to need more liquid flux on this. Want to get it nice and tinned. Get that flux in there. I don't know what level, how much flux is in the factory solder. Putting that liquid in there, and then okay, so now we got it nice and impregnated with flux. Now we're basically just going to solder from this side down, that way we're not having to work underneath ourselves. So we'll get that connected and I'll be right back. All right, to kind of show you what I was talking about, we got this row done, and we basically just went from top to bottom and moved down. The blue one's not connected. It just looks like it's sitting there. Again, these are very, very small connections. This is my finger. So just doing some delicate solder work. Now we're going to do this other row. Again, that way I don't have to work underneath this first row. So we're going to work from top to bottom, left to right. So let me get the other section connected and I'll reconvene. Okay, it's literally just a couple moments later, and we've got the white and the black connected as per the instructions you see on the screen. So I leave this disconnected while I'm doing that, and now I can articulate that back to the hex prog connector. So I've basically got to take our hex prog 2A connectors, pin them to the front of the board so I can power the board, and then put the D connector back in there so we can have our communication and everything to read that external flash. So hang tight and I'll get that hooked up and we'll go through that process. Okay, we've got everything connected. We're going to go ahead and read this. As long as everything's hooked up, it's going to go ahead and communicate. And basically, while it's communicating, there's just lights flashing, non-superimposed image. You can see what's happening here. We're just reading the flash from the two microprocessor units that are on this board, one for the engine, one for the trans. So I'm not sure which process reads first or second or whatever, or if it's just engine or engine and trans. Doesn't matter if these are comparable matching modules with software comparable software IDs. So we're going to read this. This is again our donor. This file we're pulling now is one that we technically don't need, but we always want to keep it just in case. And then we'll write the correct flash back into this one, hook it up on the bench, connect it to a scan tool, and I'll show you that the VIN number has changed, which is kind of our end goal. As long as the VIN number changes, and even if the flash doesn't change, this car will be fixed and function and work and not be a paperweight, and the customer didn't have to buy a $1,500 PCM that you cannot get, that is not in existence. So let's go ahead and name this X flash donor. Save that. Now we're going to write a flash to this. We're going to select external flash OG. We're going to double check before we click this go button. Yes, I just pulled the cover back up. This one is the used PCM, wrong VIN. We're going to click external flash OG. We're going to start writing that flash to the PCM. When this is done, we're going to find powers, grounds, comms, hook this up on the scan tool and read the data out of it, or we'll just read the flash and go see if we can actually pull up the correct VIN out of it. All right, so as you can see, we've got the flash completed. Let's go ahead and go into a bin editor and open up that bin file that I just flashed in there. So we'll go File, Open. We're using HXD. Go back to our dumps folder, our Hyundai, 241, error code couldn't fix me. Our OG that we flashed into there. This has got decoded hex on the side here. Search, find 566113. Five NPT. So there's our VIN stored. So it is in one location in here. Compare. Got our flash OG. We're going to pull up our donor. Compare the two next to each other, and it's going to point out any of the differences. Control F. 566113. And the VIN number is correct in the file we just flashed into this. So you can see this all hooked up still. What we're going to do is take all this off, put the case back on. We're going to do an attempt to see if we can pull this circuit board out of this case easily, because there is an ear broke off this circuit board, or off of this PCM. So we'll see what we can do about that, and then you guys can see the result. This is just well outside of the bounds of what any normal shop is doing. So no, it's not that he's not capable, he's not blah, blah. It's just the juice isn't worth the squeeze for him where he's at. One individual shop in a town that small shouldn't be buying these tools and equipment because the ROI isn't there. But he knows that I do these all the time, so he sent them to me and said to do this. So this isn't something that's not capable of doing. He just doesn't want to buy the tool to do it. Totally get that. And it's a slightly different skill set. So this is not fixing cars. This is fixing computers. Totally different thing. So be nice. We were just having fun.